Hello. 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 Can you able to see the screen?
Yes, ma'am.
Shall we start the class? Are you able to see the screen? Any doubt in the previous class? Any doubt? Shall we start the class, girls? Hello.
Wait one sec.
Amin.
Yes.
Hello.
Yes, Pooja.
Where is Monica?
Yeah. Shall we start the class?
Yes, ma'am.
Yeah. So our topic is Unit 4, Data and Data Analytics for IoT. So in this unit, we are going to discuss about the following topics. The various concepts are data and analytics for IoT, an introduction to data analytics for IoT, and machine learning concepts, big data analytics tools and technology, edge streaming analytics and network analytics, and securing IoT configuration. Yeah, if you take what is IoT and what is the need for data analytics in IoT. So we know in IoT, we are collecting the data from the IoT devices, and the same data is used for taking decisions, and we are making actions based on the data what we collected. So if, in IoT systems are producing vast volume of data for more and has been available for the cost. So each and every second, the IoT configuration is collecting data from the environment, and it is sending the data to the CPU processor. So the business volume of IoT is not just in the ability to connect devices, but comes from understanding the data those devices create. So to manage the data, what we collected from the IoT devices, and to process and get the knowledge and make decisions based on the data, we need to have process the data and will come out with the knowledge and information. So we need IoT data analytics to process the data from the IoT devices and to come out with decision making. So the traditionally data management was performed using relational database management systems like DBMS. So those softwares, DBMS softwares follow relational database management concept. Those data concept we cannot apply as it is with IoT data processing. So we need a specialized software which deals with IoT data and to process the data and to come out with decisions. So for that, because of that, we are going for data analytics. So what is data and analytics for IoT means? IoT has more devices and many more devices are added to IoT configuration. The data generated from those devices become very vast. So not only does this data begin to consume precious network bandwidth, but several resources are increasingly taxed in their attempt to process, sort, analyze, and process the data. So there comes the concept called big data. So the traditional database management systems are simply unprepared for the demands of what has come from the data sources called big data. The real volume of IoT is not just the connecting things, but rather in the data produced by those things, a new services you can enable via those connected things. So to use the data from IoT devices, it should be handled in a way that can be organized and controlled in a proper systematic way. A new approach to data analytics is needed for the Internet of Things. So in this unit, we are going to discuss how to collect the data from the IoT devices and how to process the data in a meaningful way. So here we are going to discuss an introduction to data analytics for IoT. It discusses the analytics for IoT and the differences between structured and unstructured data. It is also discussed how analytics relates to the IoT data. And in the second part of this unit, we will discuss machine learning concepts. So once you have the data, what you do with the data, can you gain business insights from the data? This section delivers and major types of machine learning concepts and gain business insights from the IoT data. So the big data analytics, then we will discuss the various tools and technology that can be used with the big data in one of the most commonly used terms in IoT. So this section examines some of the most common technologies used in the big data today, including the various tools that we can use for big data analytics like Hadoop, SQL, MapReduce, and MPP. Then we will discuss edge streaming analytics. IoT requires the data to be processed and analyzed as close to the endpoint as possible in real time. This section explores how streaming analytics can be used for such processing and analysis. In the fourth part, we will discuss the various network analytics, like the final, like network flow analytics using a flexible net flow for the IoT systems. And net flow can help you to better understand the function of the overall system and higher security in the IoT network. So these are the things we are going to discuss. So if you take what is the need for big data analytics in IoT means, in the world IoT, the creation of massive amount of data from sensors is common. And one of the biggest challenges, not only from the transport perspective, but also from the data management standpoint. So in our IoT configuration, we are using so many sensors and other data collection instruments. So if, once you collect the data from the configuration, we need to store the data in a proper way, and the data has to be analyzed and it should be segregated as structured and unstructured data. From the based on the type of data, we need to process using a proper data processing tool. Then based on the processing, we will come out with the proper information. Then the information will be used for making decisions, as well as the knowledge will be generated from the processed information. So a greater example of the data that can be generated from IoT is found in the commercial aviation industry. Say, for example, if you take the airlines department, airlines domain. So if you take any aircraft, it's having thousands of other sensors connected to the airplane and other systems. In fact, a single wing of a modern jumbo jet is equipped with more than 10,000 sensors. So each sensor will collect a large amount of data for each and every second, and the data will be sent to the central processing unit. So based on the data, if any abnormality is found, and we will make the decisions. Say, for example, a modern jet engines are fitted with thousands of sensors that generate a 10 GB of data per second. Per second itself, it produces more than 10 GB of data. So a modern jet engine similar to one shown in the figure, equipped with around 5,000 sensors. Therefore, a twin engine commercial aircraft with those engines operate on an average of 8 hours per day will generate more than 500 TB of data daily. So we need to process all those data, and we will come out with the information, and the information will be used for making the decision making process. So the diagram shows you a aircraft jet engines wing. So within in the single wing itself, we have more than 10,000 of sensors, and based on this data collected from the sensors, that will be sent to the IoT configuration. Then we need to process the data. So it produces more than 50 GB of data for 8 hours flying. So within those information should be processed properly, so that we will come out with the proper decision, whether the engine is perfect, any abnormality is there, we need to rectify anything. So those kind of, or to improve the performance, what are the things we need to do, all those things can be done by using the data collected from the sensors. So any doubts so far? So we start, yeah. So we started with data and analytics for IoT. So we know what is IoT. So it's connecting the unconnected things with the internet, and collecting the data from the things, and using the data remotely for processing, and coming out with a decision making. So once you collect large amount of data from any IoT, we need to store them in a proper way, and we need to analyze the data, so that we will come out with information and decision making process. So to process the data in a proper way, we are using the big data analytics concept, because our IoT devices are producing large amount of data for each and every second, and it is a dynamic data. We need to process them in a proper way. So we are using so many analytical tools. So to explain how the data is produced from any IoT devices, we taken the aircraft engine. So in the aircraft engine, we are using in the wings itself, we are using more than 10,000 sensors, and each and every sensor is collecting the data from the aircraft, and those data will be stored in a database. So we need to process those data to make the to monitor the efficiency of the jet engine. So if we know very well, the data can be classified as structured data as well as unstructured data. So I think in programming itself, we studied structured data types and unstructured data types. So here in case of IoT and big data analytics, what do you mean by structured data and unstructured data means? A structured data are more important class. We have two typical types called structured data and unstructured data. So what is unstructured data means? The data follows a model or schema. So if it is fitted into a particular schema or model, we will call it as structured data. Say for example, the traditional database management system, like our relational database management system, RDBMS, will come under structured data. So here we follow a particular schema, and we'll store the data in a table format. So other examples of structured data are, so it is having its predefined structure, like say the spreadsheet, where the data occupies a specific cell and can be explicitly defined and re-referenced. So if you take Excel sheet or any spreadsheet or MS Excel sheet, so we have cells, rows and columns. The data, we can apply the data type and other calculations on each and every cell. And if you take the banking transaction and the invoices, to compute log files and router configuration. So in any banking software, we are using relational database management system or MySQL or something. So there also we are following the tables. So each table will be having its own schema and data types. So we can apply all the queries and constraints on each and every table. So it will come under structured data. And if you take IoT sensor, data often uses structured values such as temperature, pressure, and humidity. So if you are making an IoT device to measure the temperature of any city, so it will be having the columns like temperature, pressure, and humidity. So those data will be stored in a tabulated form. So each and every field attribute will have its own parameters like data type, constraints, size, all those things will be applied on each and every attribute. So because of the highly organized format of structured data, we can easily process them and we can apply any query or constraint on them. So it is easy to manage. From custom scripts to commercial software like Microsoft Excel, most people are familiar with the comfortable with the working of the structured data. So if it is structured data, we can, it's having its own schema. So processing and handling of structured data is very easy. And if you take the unstructured data, lacks of logical schema for understanding and decoding the data through traditional programming means. Say, for example, the data which is collected from the like email. So the email, say the data type includes text not fit neatly into a predefined data model is classified as unstructured data. The most of the data what we are getting from business are called unstructured data because of this fact the data analytics methods that can be applied to unstructured data and such as the cognitive computing and machine learning and gaming can be applied to come out with the structured format. Say, for example, the data which is collected from email also will come under unstructured data because the email will be combination of text, images, and other things, and it will have so many attachments. So it is combination of both the structured and unstructured data. So the table shows you a comparison between structured and unstructured data. So if it is structured data, so it will be organized and stored in a well defined format. So it will be having rows and columns and organizing format will be followed. It may be in the form of spreadsheets or database systems, like it may be relational database system or hierarchical relational data system, or say for example, the tables will come under relational database management system, and the tree structures, graph structures will come under hierarchical database management. So if you take the unstructured data, so it will be having a conform to a model. Say, for example, you will have some textual data, images, audio, video, speech. So it will be combination of all. We cannot put all those data in a common format. So that is, if the data is in the form of logical, and if it is, it can be stored in various data types like integer character, float, and double character. So we can put it in a table and we can apply the operations on them. But if it is in the form of images, speech, audio, video, textual information, so we cannot able to process them using a single software. So that will come under unstructured one. And we have the third type called semi-structured data. So a third data classification is called semi-structured. It is sometimes, it is an hybrid model. It is combination of both structured and unstructured data. So the semi-structured data is a hybrid of structured and unstructured. So it shares the characteristics of both structured and unstructured. While not relational, semi-structured data contain a certain schema and consistency. So it will have a partial schema and it will be partially consistent with the database. Say, for example, email is a good example of semi-structured data as fields are well defined, but the content contained in the body field and attachments is unstructured. So the email will come under hybrid model like semi-structured. So the attachments may be unstructured and the body of the email text subject will be structured one. So the other examples of semi-structured data are JavaScripts, object notification, and say the XML scripts like extensible markup language, XML, DHML will come under semi-structured. So any doubt so far? Any doubts, students?
No, ma'am.
Yeah. So after the introduction part, we discussed about the structured and semi-structured and unstructured data. So what is structured and what is unstructured? What is semi-structured? What is the example? What is the advantage and disadvantage? Whether we can able to process or we cannot able to process. So our next topic is data in motion versus data at rest. So we know very well, we already studied in data, other languages, classes and objects, static data and dynamic data. So static means it is predefined, the values are fixed, it will not change throughout the programming. And if it is dynamic one, it takes different values during different occurrences. The same way, data in motion versus data in rest. So data in motion means that it is a dynamic part of the data, and data in at rest means it is in static form. So as in most networks, data in IoT networks is either a transit data in motion, or it may be held or stored data at rest. Examples of data in motion includes traditional client-server exchanges, web browsing, and file transfer and emails, because the values of the data will change each and every second. It takes different values at different occurrences. So data saved to a hard drive, to storage array or USB drive is data at rest. So once you store the data in any hard disk or any storage, secondary storage devices or USB pen, so that will be constant. Again, if you open the data and if you modify, then only it will, the other version will be created. Otherwise, we'll call it as it is data in rest. So from the IoT perspective, the data from smart objects is considered as data in motion, because smart objects, IoT devices are collecting the data each and every second, and the values changes each and every moment. So we will call it as data in motion. So this is often processed at the edge using fog computing. When the data is processed at the edge, it may filtered and deleted, forwarded, forward at node in the data center. So whatever data dynamically we are collecting will be stored in the data store. Then it will be taken for processing. So any doubt what is data in motion and what is data in rest? So if you take data at rest in IoT networks can be typically found in IoT brokers or in some sort of storage array. So say for example, the myread tools, especially tools for structured data in relational databases, are available for data analytics perspective. So they are best known tools for, the best known tool for processing those kind of data is called Hadoop. Hadoop not only helps in the data processing, but it can be used for data storage also. So the IoT data analytics overview. So how we are processing the IoT big data and how it is processed and how it can be stored. So the true importance of IoT data from smart objects is realized only when the analytics of the data leads to actionable business intelligence and insights. So whatever data we are collecting from the IoT devices has to be stored in a proper way, and it should be analyzed to come out with information. Data analytics is typically broken down by three types of results. So the four types of data analytics results are, so the data what we are processing can be descriptive, so or it can be diagnostic, or it may be predictive or perspective data. So what is a descriptive data means? A descriptive data analysis tells you what is happening either now or in the past. For example, the thermometer in a truck engine reports temperature values every second. So the descriptive kind of data will tell you what is happening in the system, and what are the data it is recording from the system. It will say what is going on in the IoT devices. And if you take the diagnostic kind of data, so when you are interested in the why, diagnostic data analysis can provide the answer. So by using the diagnostic kind of data, we can get the answer for any query. Continuing with the example of the temperature sensor in the truck engine, you might wonder why the truck engine is failed. So by analyzing the data what we collected already, we can come out with the solution or we can find out the reason for why this truck engine is not functioning, what is the reason for failure. And if you take the predictive data, predictive analysis aims in football problems or issues before they occur. So, for example, the historical values of the temperature for a truck engine, predictive analysis could provide an estimate on the remaining life of the certain components in the engine. So we can predict what will happen in future. So the past 1 year, the truck is functioning properly because of some reason it's stuck. Now in future also, if the same condition occurs, it may go, it will not function. So based on the previous history of data, we can come out with the problems and we can predict what will happen in the near future. So those kind of data is called predictive. So we can predict based on the data what we collected, and this kind of data will be useful for say in share market also. By analyzing the last 1 year data, we can say when the share will rise and when the share market particular share will go in down. So based on which criteria it's increasing its value and it's decreasing the share market value. And if you take the fourth type, it is prescriptive. Prescriptive analysis goes a step beyond predictive, recommends a solution for upcoming problems. So if this condition occurs, if this situation occurs, this is going to happen. So to avoid that, we need to take we need to take some remedial measures to come out with the problem. A prescriptive analysis of the temperature data from a truck engine might calculate various alternatives to co-effectively maintain our truck. So if this is the condition, so if this condition occurs, these are the things these are the things will happen to the system. And to avoid that particular worst condition, what are the remedial methods or what are the solutions we need to apply, that can be found by using prescriptive analysis. So these are the 4 types of data analytics. So we will say so the diagram shows you the types of data analysis results. The first one is descriptive, second one is diagnostic, third one is predictive, and fourth one is prescriptive. So in the descriptive, we will say what is happening. This data will give you what is going on in the system. And in case of diagnostic data, what we are getting from the system, it will tell you why did it happened. And if you take the predictive one, what is likely to happen in future, and prescriptive one, it will tell you what should I do about the so these are the 4 types of analysis. So we take the data technologies like collect, integrate, process, and aggregate and visualize the data. So we have this diagram has 3 layers: data layer, big data technologies, and what are the analysis tools we can apply on the data to come out with the solution. So if you take data, we have raw and processed network, chips of data. So we'll have the alarm system data, or mobile internet data, or machine and sensor data, or it may be any usage data, or the data which is received from the video streaming, and social media data, or relationships and social influence kind of data, email and messaging data, CRM, customer relationship management, and ERP, enterprise resource planning data, or we'll have the geolocation data. So the data is collected from various resources. So it may be the video kind of data can be, we can get it from the YouTube channels, and usage data may be the Google search and other search engines will provide you which kind of data people are searching for. And social media data, it may be Twitter or Facebook or WhatsApp, what kind of data people is most interested. And if you say the around processed network chips of data, or any relationship and social influence data. So this kind of data we will collect it from the internet. So any data which is collected in VAST is called big data. So once you collect the data, we need to collect the similar kind of data. Then we will integrate the data, we will process the data, and then we will come out with aggregation. Then based on the aggregation, we will visualize what is going to happen. The data what we collected from big data technologies, if you apply to descriptive kind of analytics, we will come out with, it will say what will happen, what is happening in the society. And if you apply the same data, big data what we collected, to diagnostic kind of analytics, so we can diagnose what will happen in what is going on whether it is good one or bad one. So the kind of diagnosis can be done. The same way, if you apply the data to predictive analytics, we can predict what will happen next to 2 months or 3 months or 6 months, short term, 1 year or 2 years. So, or if it is prescriptive, so we can come out with the solution. So the diagram shows you the all 4 types of data analysis results. So any doubt? So the application of value and complexity factors to the types of data analysis. So if you take the complexity in the x-axis and volume in the y-axis, so how much data we are feeding. So in case of descriptive analysis, the complexity is very less. The volume of data we can process using descriptive analysis also very less. So if you go for diagnostic analysis, the complexity increases and it can process a little more amount of data. And in case of a predictive analysis, the data volume also increases, complexity also increases. In a prescriptive analysis, it can process a large amount of data and the complexity also very high. So any doubt so far? The IoT data analytics overview. So we have 4 types of data analysis, descriptive, diagnostic, predictive, and prescriptive. So any doubt in this topic? Shall we move to the next topic? So the next subheading is called IoT data analytics and challenges. So while processing a large amount of data in IoT, what are the challenges we will face means the two main challenges are scaling problems and velocity of data. Scaling means we know very well. Scale means how much amount of data we can process, whether it is 1 GB of data, 2 GB or 3 GB, or maximum 10 GB or 100 GB. How much we can the system, the analytics tool can handle at a time. And the velocity of data means with relational database, it is critical that the schema to be designed correctly from the beginning, and changing it later can slow the or stop the database from operating. So we know very well if you are using any relational database system like RDBMS or SQL or MySQL, initially we are defining the table structure will be defined. So that is called a schema. So it cannot be changed in future. So otherwise, if we want to change now, we need to go for alter table query so that we can change the table. And IoT data, however, it is volatile in the sense that the data model is likely to change and evolve over time. And if you take our IoT data, it is dynamic in nature. So the dynamic schema is often required so that the data model changes can be made daily or even hourly. So these are the 2 problems which we will face while doing the data analytics with IoT devices. Scaling problem. So the scaling problem is the performance issues required more hardware and architectural changes, and velocity of the data, how much data it can process, whether it can process the static data or dynamic data. So any doubts so far? Shall we proceed? Any doubt?
No, ma'am.
Yeah, shall we continue?
Yes, ma'am.
Yeah, 1 minute.